If you take the time to investigate the origin of some common device, you'll often find an interesting story. This compass, for instance. We all know what it is. It's a device for determining magnetic north. Hold the compass still and level, and in a few seconds, the needle aligns with the Earth's magnetic field and indicates magnetic north. Once north is established, the other cardinal directions, south, east, and west, are also determined. In our modern culture, north is given prominence. We reference north to determine the other cardinal points. This was not always the case. It appears that for many ancient cultures, east was the most important. This seems reasonable. The sun rising in the east is an inspiring and important event. The day begins. Many linguists believe that the words representing the cardinal points originated in an ancient ancestor language called Proto-Indo-European, the root language for almost 50% of the languages spoken today. The word east is derived from an early word for dawn. Standing at dawn, facing the rising sun, we are looking east. The word north is descended from the same language group and is derived from an ancient term that meant to the left of. Pointing to the left while watching the sunrise, and you are pointing north. West is derived from an ancient term that referred to evening twilight, the setting sun. Watch the sunset, and you are facing west. South derives from a word for sun or region of the sun. Face the sun at midday and you are looking south. The labels on your compass have ancient roots. The magnetic compass has been around for a long time. We don't know who first discovered that a magnetized iron needle will align itself pointing north and south, but the first serious use of magnetism appears to have occurred in China, with reference in Chinese literature going back to the 4th century BC. This balanced magnetized spoon from the Han Dynasty aligns itself with the Earth's magnetic field. The handle of the spoon points south. This assists in the alignment of sacred structures, homes, and burial sites according to the tenets of Feng Shui. It is likely that a device like the south-seeking spoon was an important step in the evolution of the compass, and the Chinese may have been the first to realize that a magnetic device capable of independently determining direction would be a powerful aid to navigation at sea. Early navigation at sea was accomplished by following shorelines and observing the sun and stars. Attempts to travel great distances at sea often ended in disaster when dense fog descended, leaving the ship blind. Sailing in circles, the voyage often ended with a shipwreck on a rocky shoreline. The appearance of the compass changed that. The rotating magnetized needle reliably found and displayed north, confirming the direction the ship was sailing, even in a dense fog. By the 17th century, much of the world had been explored and mapped. The compass played an important role in this accomplishment. Let's take a look at the science and technology behind the compass. You're probably familiar with the basic interactions of magnets. Magnets strongly attract three metals: iron, nickel, and cobalt. A magnet has a north pole and south pole. Opposite poles attract. Like poles repel. The North Pole is defined as the end of the magnet that is attracted towards the Earth's geographic North Pole. The Earth has a magnetic field. This field originates in molten iron at the Earth's core. The South Pole of the Earth's magnetic field is actually located close to the Earth's geographic North Pole, explaining why the North Pole of a magnet is attracted toward the north. A compass consists of a magnetized needle, free to rotate, with the cardinal directions printed on a dial or bezel ring. Holding the compass level and steady for a few seconds, the magnet locks on and indicates magnetic north. We can rotate the compass and align the needle with north on the dial. This also orients the cardinal points. We have determined magnetic north, south, east, and west. There is a problem. It turns out there's another north, true north, and it differs from magnetic north. True north is essential for precision navigation. As you know, the Earth spins, rotating on an imaginary axle. The ends of this imaginary axle represent true north and true south. True north is the preferred reference for maps and navigation. Unfortunately, magnetic north is not aligned with true north. Viewed from above, we can see that the north geographic pole and the north magnetic pole are over 1,000 kilometers apart. Here's what this means for someone using a compass. I live here in the Ottawa Valley in Canada. From my location, my compass is pointing here, and true north is here. There's a difference of close to 13 degrees between magnetic north and true north. This difference is called magnetic declination. Cartographers label this declination 13 degrees west, because from this location the magnetic pole is west of the North Pole. Magnetic declination varies with location on Earth. This animation shows the approximate orientation of the north magnetic and north geographic poles. A viewer at this location would see a declination angle that looks like this. As the observer moves to different locations on the planet, the magnetic declination angle changes. This means to determine true north when using a magnetic compass, you must know the declination for the area you are navigating from. Topographical maps indicate magnetic declination, and there are a number of online sites with declination information for all locations on Earth. Here is how you use declination and a compass to determine true north. Holding the compass steady and level, the needle quickly locates magnetic north. Rotating the compass, we can align north on the dial with the needle. We have now aligned magnetic north with the cardinal points. To determine true north, we have to know the local declination. Here it is 13 degrees west. This compass has a declination scale in increments of 2 degrees. We can locate true north by rotating the compass until the needle is pointing at 13 degrees west on the declination scale. The needle is locked on magnetic north, but the dial is now aligned with true north. The ability to orient and properly use all the features of a compass to navigate through unfamiliar terrain is a sophisticated skill. I'll leave that for another video. For more science and technology related videos and projects, visit our website, hylaroad.com. Follow the projects link.